consider the insertion sort algorithm and the selection sort algorithms. I think you'll see these are pretty straightforward. So let's do the insertion sort algorithm first. I have a list here, unsorted, called list. Index positions the content. Temporary variable for the swaps. Okay, so the insertion sort works like this. What it does is it gradually builds an increasingly large sorted list. So it starts first with just these two, and it moves the number on the right of this list, sublist, into its correct position, sorted position. So the 12 and the 54 swap. Right, so the 12 goes there, 54 goes there, 12 goes there. Okay? Now, this second time through the loop, it moves the 3 into its correct position within this sublist. So the 3 goes there, 54 goes there, 3 goes there, the 3 goes there again, there, there. Okay? So as you can see, from this point to the left, this is a sorted list. But we haven't even looked at all of these elements yet. That's the way the insertion sort works. So you just get the hang of this now at the fourth time iteration. It finds that the 68 is already where it belongs, right? So it doesn't have to do anything. No movement's necessary. Fifth time through the list. So again, it goes, right, the 31 swaps, blah, 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 down to here, right? So we don't need to do all of them. You get the idea. So here's the loop structure for this. The outer loop is going to go from 1 to 10, or to size, right? So that's down here, the outer loop, 1 to the number of elements, right, which is size minus 1. Okay, what about the inner loop? Well, the inner loop is going to go, first time it will just go from here, because the inner loop is comparing this element, the element at its position, to the one less than it, right? So that's the first iteration of the inner loop. And the inner loop, notice, is getting its starting value from the current value of the outer loop, right? So the outer loop starts at 1. So the inner loop, first time, is 1. As long as 1 is greater than 0, it is. So it'll do the loop once, the body once, and that will swap. If they're unsorted, it will swap them, right? And then decrements, and now IL is not greater than 0, so it just does it that one time. The second time through, it starts here and goes down to here, right? And the third time through, like that, right? All the way to, right, the last time, it's going to go take that last element and make sure that it's in the correct position within the larger array, all right? So this is where that n squared stuff comes from. Oops, that's wrong. N squared, order of n squared. I should do a big O here. Let's do that again. Big O, n squared. Because although it's n times, it's doing n, or it's actually doing n plus n minus 1 plus n minus 2 plus n minus 3 all the way down to 1, right? But the fact is that this is, the way this factors out, there's an n squared in the formula minus something. The n squared so swamps what is subtracted from the other factors that we just call these order of n squared. Okay, so that's insertion sort. So let me get set up for selection sort. Selection sort is basically doing the algorithm that you did for a recent assignment to find the smallest element in the list or the position of the smallest element, doing that over and over again until the list is sorted. So let's take a look at this. So conceptually the way this works is we say as a guess that that's the smallest position, right? This smallest element is in that position. Then and that's determined by the outer loop. So then in the inner loop, we go from one larger than the outer loop all the way to the end, saying, okay, is what's at this position less than what's at the 0 position, right? Or the smallest position, because that's the arrow indicates that we're guessing that that's the smallest position. We've got a variable called smallest, which that arrow represents, right? Is that smaller than what's at the smallest position? No, 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 none of them are. Okay, cool. So the inner loop finishes. The outer loop now moves this up to here. And again, we go through the inner loop. Is that smaller? No, 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 no. Okay. Right? Again, is anything smaller than this? Well, that's our first. That's the one that it ends up being. So now what we do is we swap the 26 and the 54. Right? And now we move to here and we do that again. Right, so that's the selection sort. And the loop structure is the outer loop goes from here, right, from 0 to the number of elements, sorry, the last index position. Right, so the outer loop's going to go from 0 to 10. And the inner loop will go from, it will go from 1 greater than whatever the outer loop is up to. So the outer loop starts here, right? So the inner loop is going to go from here to here, checking each of these things to see if they are, let's move this back here, checking each of the elements to see if they're smaller than the smallest, what's at the 0 position, or what the smallest variable is pointing to, the index position that the smallest variable is pointing to. And if it is, then we move the smallest variable to be where it finds the smallest one in this subarray, and then we swap, right? And then the second time through, we guess that the smallest position is here, because we've already know that we found the very smallest. So it's here, and we don't need to look at this part of the array anymore because we know we've already placed the smallest there. So in the second time through, we guess that the smallest position is here, right at the 1. So let's move this over. Right, that's our guess at where the smallest position is. And we go, our inner loop now goes from 1 greater than that. Oops, let's go back to blue. 1 greater than that, all the way to the end, and so on, right? And then again, from the third time, that'll be our guess at where the smallest is. So we go from 1 greater than that to the end. Fourth time, that's where our guess at where the smallest is. So we'll go from 1 greater than that to the end, all the way down to, right, where we are comparing this one to itself. So we could actually stop one before that. But that's a technicality. Okay, so that's the way the selection sort works. So just to go through the algorithm a little bit, because we kind of neglected that as we were working up here. So our outer loop goes from 0 to the last index position. We guess that our smallest position is whatever the outer loop is currently. our inner loop goes from the outer loop plus 1, that's what these guys are. As long as the inner loop is less than size, we go increment it. And if it finds a element out here that is less than what the smallest position is, then it makes smallest position equal to that. And then at the end, it swaps the swap only occurs once after the loop is finished. We swap whatever's at the current smallest position with whatever OL is up to. So if OL was up to here, or we found the smallest position, we'd swap that element with where OL is up to, right? And that is selection sort. So I hope that's clear. These are in some ways sort of inverses of each other, right? So the insertion sort gradually builds a sorted sublist, not looking at anything to the right of where the current outer loop position is. The selection sort looks through the entire list, not moving anything until it's found the smallest element in the unsorted part of the list, and then moves it to the beginning of that, and then says, okay, now that those elements are in the element I just moved is in its correct position. Now let's do it again, starting with the one just to the right of that. Do it again, find the smallest, move it to there. Okay, then that's good, and so on. Okay, that's selection sort. Select the smallest element, place it where it belongs. Insertion sort is take the next unsorted element and insert it into the sublist to the left of that is insert it in the correct place so that the sublist to the left of that remains sorted. They're both n-squared sorts with not a whole lot of difference between them. The insertion sort is, as you may have noticed, you could short circuit it as soon as an element, so you see that an element doesn't need to move left, you can exit the inner loop, which can save you a bit of time. But it's really, in the greater scheme of things, it's kind of insignificant. Okay, hope that helps. Thanks.